In this video, we are going to demonstrate programming a very simple elevator application in flowchart programming using a Velocio PLC. This particular example came about due to a customer request. The customer had just such an application where he's got a small system it's an elevator that would typically or traditionally be called a dumbwaiter. It's not moving people up and down. It's a small elevator moving material between 5 floors, between the basement up to the 4th floor. At each floor there is a sensor that will sense whether the elevator is there. There's a motor driving the elevator up and down, and there's a single panel, an operator panel with 5 buttons on it to select what floor to go to. And then there's also a buzzer that we want to turn on and provide a little noise before moving. We'll do that for about 3 seconds. And there is also a door sensor to make sure that the door is closed before the elevator moves. We've written a program to perform these operations, and we'll show it to you here. First of all, we have our inputs and outputs. The input definitions, as you can see here, we have got a digital input for the button for each floor and a proximity sensor that senses are we at that floor. So we've got through basement, floors 1, 2, 3, and 4. In addition to that, we've got an input that is a door close sensor. We call it door prox. These are all proximity sensors. And we've got a sensor that senses the upper limit. For outputs, it's very simple. We've got an elevator motor where we can provide energy to or electricity to the motor to turn it on, and then we've got a direction up or down. And in addition to that, we've got the bell that we want to sound for about 3 seconds before we move. The program to accomplish the control that we need to perform here is very straightforward, and it's done in a state machine style using flowchart programming. I can just skim down here, and you can see the program. It's fair length, but it is a lot of very basic operations. We'll go through and describe it, and then we'll put it in run mode and debug and watch it run a little bit. So the first thing we've got to do with any state machine program is we've got to create a state variable. We call this one eStep, and then in this application, we're also going to have a couple of timers. We want to time the bell, and we also want to time out the moves. If we move for too long a period of time, we want to turn the motors off. There's something wrong. So we've got a move timer, and we also have established a maximum move time, and I've randomly set it for 120 seconds or 2 minutes here. And then after we do that, we go into our loop. If you take a look at the program overall, this is just one big loop. We go through, we do something, and we come back around, we check the next thing. And within this loop, we've got 5 steps or 5 states in our state machine. We initialize our state machine to step 1. So the very first thing that we do is come down and we see that we are at step 1. And then we put decision blocks here. We want to know, okay, am I at a particular floor, and which floor am I located at? So we look at the proximity sensors and we say, are we at the basement, 1st floor, 2nd floor, and so forth. And if we sense one of those floors, we copy that floor number into our current floor position. We're keeping track of where we are. So we've got 0 through 4 here. And if we sense one of those floors, we change our state in our state machine to state 3 then, which is the state that we'll look at a little later here, which it's where we're waiting for somebody to push a button. Okay, now there is another possibility, and this generally will happen if there's been a power outage and something's been moved around somehow, not powered by the system, is you may not know what state you're in. So if we don't match or we don't sense any of these sensors here, we need to go to some known position. So what we do is if we don't find where we are, we set our step to step 3. We reset our bell timer because we're going to start to move. And then again, what will happen in program execution is we come out of here, come back around, and we say, are we state 1 now? No. Are we state 2? Yes, we are, because we just changed it to state 2. And the first thing we do is we check to see whether our bell timer is less than 3 seconds. Now, right above here, we just went through it and we reset the time to 0. So for 3 seconds, we are going to be less than 3 seconds. So what'll happen is we turn the bell on, keep looping back around, checking to see whether we are greater than 3 seconds. And as soon as we are, we'll drop down, turn the bell off, and we'll begin our move. Now we have to either move up or down. In this case, I decided, okay, we're gonna move down until we hit a known position. So we turn the elevator on and we tell it to go in the down position. We've got this variable elevator, or the output actually, elevator up. We put a 0 into it. That is negative. It's not going up. And we put the value of 1 into the elevator. That's turning a digital output on. That's the same as if we had done a turn on off block like the one here, and we had turned elevator motor on and then add a separate block to have turn elevator up off. We simply use a copy block because it's more efficient. We can do 2 operations in the same block. And then we check, okay, do we see our sensors? Okay, initially, the very first pass through, we're not going to see any of these sensors, but we'll keep going around our loop until we finally sense a door or a floor sensor, and we look for basement, floor 1, 2, and 3. Since we're going down, we should never hit floor 4. And as soon as we hit a sensor, what we will do is we'll establish what floor we're at. So if we're in the basement, that's floor 0. We'll copy a 0 into current floor. We turn the elevator motor off by simply writing a 0 into the elevator motor output, and then we set to step 3. We want to go to the area of our code where we're waiting for a button. And we do the same thing for whichever floor we're on. You can see all these blocks are the same. The only difference between them is what current floor we set to. So then we are in a position where we are in state 3, and we keep looping until something happens. In step 3, first thing we do is we check to see whether our door is closed. If it's not closed, we don't allow anything to happen. So if you follow the door not closed path here, you see it skips everything and it'll loop around, and it's going to continue to check until that door is closed. If the door is closed, then we wait and we see if somebody pushes a button. If the button's pushed, depending on which button is pushed, we will copy a value into a variable we called target floor, and it's whichever floor they push. So basement is 0, floor 2 is 2, floor 3 is 3, and so forth. And if the button is pushed, then the next thing we need to do is determine, okay, are we there, or we need to go up or down. So if we'll check to see whether the target floor is greater than our current floor. If it is, we need to move up. And in that case, moving up is state 4. So we will zero the bell timer, set state 4, and also zero the move timer. So for our timeout, if our target floor is below our current floor, we do the same thing, except we set our state machine step to 5, which is the move down state or step. If we're not greater and we're not less than our current floor, then they've selected the floor we are currently at, so we don't move, we don't do anything. And then we come down to step 4. Remember, this is our move up step, and it's the same kind of thing that we saw in step 2, where for 3 seconds we will ring the buzzer. It's going to keep coming through here. This is a continuous loop, and we'll be turning the bell on for that 3 seconds. As soon as the 3 seconds is over, we'll turn the bell off, and then we will turn the elevator motor on and in the up direction. And it will keep looping and doing that, and while we're doing it, we look for our proximity switches for the different floors. So we check to see, okay, do we sense floor 1, or is our target floor 1? First, we're looking to see, is this our target, and if it is our target, do we sense that we are at that target? And we do that for all 4 floors here that are options for moving up. And then as soon as we sense that we are, let's say our target is we need to go to floor 3, it'll bounce down through. Are we looking for floor 1? No. Are we looking for floor 2? No. Are we looking for floor 3? Yes. We'll come across, and if our proximity sensor is sensed, or as soon as it's sensed, we change our current floor to 3, and we turn the motor off, and we go back to step 3, which is our step where we're waiting for the next button to be pushed. It's the same type of thing for the down. Is we ring the bell for 3 seconds, and then after the 3 seconds, we tell the motor to turn on and go in the down direction. And while it's moving down, we look for the proximity sensors for the different floors to see, okay, where am I trying to go? Say if I'm trying to go to floor 1, we'll come down, we'll take this branch. Do I see the floor 1 proximity sensor? As soon as I do, we set our current floor to 1, turn the motor off, and go back to step 3, where we're waiting for the next button to be pushed. So that's the program. It is it's quite a few program blocks, but as you can see, it is very straightforward and very logical, and that's what state machine programming does for you. It's, okay, I'm in this position, what can I do, what do I want to do, and you simply provide the logic to operate the functions that are possible there or desirable in that position, and then something happens and you transition to another state, and whatever is available in that state, that's what you do there. So that's the program style. That's the function of it. Let's go ahead and program the PLC, and we can watch it a little bit. So I just programmed the PLC. I've got simulator sticks plugged into the PLC. We're having to use an ACE-22 PLC. And I've got toggle switches that I can use to simulate the different digital inputs that we've got in the system. Let's look at it in debug mode so we can see what's going on. And right now, what I'll do is we'll start it up, and we'll say that we are on the second floor. So I'm gonna close the second floor sensor. And why don't I just single step through it here so you can see what happens in program logic, understanding that this happens, the logic solve happens multiple times per millisecond. So this is going at light speed. So we have set our step to 1. We're starting some timers, which we won't be able to see operate in single step mode. And you can see we can switch back and forth between name and value. So when we step down here, we're going to check whether our step is equal to 1. If we go to value, we can see that it is 1. The other indication is the function block in the program turns green, which tells you that if this block is executed, you'll take the yes path. So let's single step again. We're going to check to see, do we sense the basement sensor? No, we don't. Do we sense the first floor sensor? No, we don't. Do we sense the second floor sensor? Yes, we do. So we set our current floor to 2 and set our state machine step to step 3 now. So what I just did there, I'll back out of it a little bit and see what happened, is I single stepped and we'll come out of here around and we hit this step again where we are, this block again where we are checking to see whether we are step 1. Well, in this case we're not. You can see the decision block has turned red, which means that it's going to take the no path. If we take a look at the value here, we can see that our value of each step is 3. So single stepping on again, we're not step 2, we are step 3. The door proximity sensor is not active, so what's going to happen is we won't execute any logic to check to see whether the button is pressed. I'll back out so you can see it again. And what will happen is the answer down here will be no. It comes down, around, up, and back up to check our state again. It'll keep doing that. I'll keep stepping through over and over again until we close the door. So I'll just close the door here and you see that it would come down, and now the door is closed. So next thing, as long as the door is closed, we'll come across and we will start checking the various buttons. I'll let this run in real time, and we'll see a little bit about what happens here. As soon as let's put a breakpoint in. We are in on floor 2 right now. I'm going to check. I'm going to put a breakpoint where if button 3 is pressed, we should hit this breakpoint. So I'm going to toggle the button for floor 3. We see that the logic block turned green and we hit that breakpoint. So we're going to copy 3 into target. Okay, and we check, okay, are we above, is the target floor above where we are? Well, 3 is greater than 2, so we should step across here and like so. And what's going to happen is we will zero our timers. You can see they've got values now, but as soon as I execute this block, they'll go back to 0. And I'll show you that block again. These were the values now for those timers. They were set to 0. and we should be in step 4, and that'll do the move down. I'm not going to go through all the operations here. You can take a look at the code for this, but this is a very basic example. It demonstrates a state machine operation for a elevator, and it's typical of a lot of small programs that you can do in flowcharts quite readily. Thank you for listening, and we look forward to you watching other videos put out by Velocio.